Awesome. So we're going to talk about technical interview problems. We've been talking about behavioral interview problems. We're going to talk about and practice technical interview problems today, and I believe Friday and Monday as well, if I have that correct. And whiteboarding is sort of the catch-all term here for like a technical interview problem or a programming problem. Um, Traditionally, it refers to like an in-person interview where we're actually like writing code on a whiteboard, and it was often an algorithm-related problem. But I and we are really using the term to encompass leak code and any program problem you might encounter in leak code or in the interview process. And this really applies to all of them, though it does focus a bit on an actual real interviewer because there's some process steps here that are a little more focused around that. Though to be honest, even for like leak code, if there's some sort of timed coding challenge, pretty much the same process applies, and you just need to talk to yourself. Um, it's a pretty straightforward process, and I'll return to this slide in a minute. It was a nice way to start off the talk. Um, to kind of set the stage for what we're talking about here, I talked about the interview process yesterday. Essentially, 3 to 5 interviews, right? And that's sort of like the max scenario where like each is about an hour. And so you can expect like 1 to 3 technical interviews, roughly. One of which might be a take home project, one of which could be like a 4 hour, multi hour on site, or you might have like 2 rounds of 1 hour technical interviews. And really, what Benjamin and I are showing you guys today is focused on the sort of like the 40-minute to 1 hour technical interview where there's a problem that you and the interviewer are working on together. However, again, this process is really useful for like many parts of the technical interview. Um, and before I dive too much into this, were there any questions around like sort of the technical interview process from the talk yesterday that people had on their minds or just things that people were curious about? Cool. So historically, your whiteboarding problem was in person. It meant writing code on a whiteboard to solve a technical challenge, or maybe doing some design. You may be asked to do a little bit of database design. It's less likely for a junior role than not impossible. This all sort of stems from computer science curriculum because basically the best way that people could figure out to evaluate someone's programming skill was essentially to give them algorithm problems. And as time has gone on, it's been like all sorts of programming problems, not just like straight up algorithm problems, which are actually probably less than 50% of what you'll see. Though there's a lot of value in learning them because if you can do some algorithm problems well, you can do a lot of the less complex ones well as well. Um, Today, as I mentioned yesterday, this has evolved to this will usually happen over Zoom. You'll write code, you might not run the code. And so, very critically, this means you may not be able to use ChatGPT because this might be done in a Google Docs, or your interviewer might ask you not to use, GitHub Copilot or a tool like that. I would definitely ask in advance in email, simply ask what their policy is on these AI tools. Some companies might say go for it. Other companies might say we really want you to kind of do your own work. And honestly, I am not certain. I think it's all over the place right now because everyone's trying to figure out what these things mean for technical interview assessments. It's focused on the thought process. You can definitely get hired and not finish the problem. What the interviewer wants to see is that you can come up with a reasonable solution and understand the problem well and explain it well and collaborate well. The interviewer is actually going to help you. They're going to help you and they want to see how you think. Because as I mentioned yesterday, especially as a junior hire, but really any hire, like there's going to be a lot of mentoring for your first 3 to 6 months. So it's 60% process, 40% solving the problem. When you do well, the interviewer will push you. Um, And someone from Sierra Platoon came up with the saying, which I think is really true. The interviewer is not your enemy, they're your ally. So the reason we kind of harp on all this, and I'll share the link to this doc, and really you all should do a bunch of simple LeetCode problems to practice this process so that on game day, so to speak, you're comfortable and you have your system, because everyone's nervous, especially your first interview, but just generally interviews. And practicing and having process is a hedge against like game day anxiety. So now let me pop over to this slide, because this is a much better synopsis, and then I'll kind of talk in a little more detail. But essentially, repeat the question. Make sure you understand what the algorithm that you're implementing needs to do, what its inputs are, and what its outputs are. Explain to the interviewer your approach to solving it. Like, this is the approach I think will work. Write out some pseudocode with your interviewer, talk it through with them, then start writing like your simplest possible implementation. And then you can talk about how you would test it. You can talk about edge cases, and the interviewer may have follow-ups for you. And probably the most important thing here is to always be communicating and speaking your mind, and never go silent. Don't be afraid to ask questions. You're expected to ask questions. Often these problems are kind of designed where you have to ask questions to succeed at them. And if you get stuck, ask for help. The interviewer is really your ally here. And again, 60% process, 40% solution. Sometimes it is not fun if you're struggling in a technical interview. However, it's really important not to give up and to continue, both for the benefit of your own learning and building up those skills, but also because, to be honest, that is kind of part of what's being evaluated in these as well. Because as you all have learned, like, debugging can be frustrating and time consuming. And so that is part of what's being assessed here. So to kind of reiterate, like, whenever you get a LeetCode problem or a whiteboarding problem, start by literally reading back the question to the interviewer. Take some notes as you go. You want to make sure that you understand the problem. You want to make sure the interviewer knows you understand the problem. And you want to make sure you both understand the problem the same way, that you didn't like interpret the wording one way, but the interviewer does another, or sometimes there might be a typo or a mistake. This is part of your responsibility here. So this is actually the most useful thing you can do. And it gives you time to let your brain get into gear. Then you want to start talking through like the algorithm. Not in the sense of like a binary search or whatever, but whatever the problem is asking you to do, that's the algorithm. Like, talk through what is it expecting you to do, and I would write it down as comments, or sometimes make notes on a piece of paper and tell the interviewer that you're making notes. Think about, what are the inputs? Is it a particular kind of variable, a string, an integer, a dictionary? As you think through the problem, think about edge cases. If you have to deal with zero or special characters, and just make notes of them. And again, make notes as a comment so the interviewer knows you're aware, and so that you can have a checklist to come back to later. It's always good to ask about input size if it's not specified. Like, if you're writing some function that takes an array, it never hurts to ask the interviewer, like, how big is the array? Like 100 items, 1,000 items, 10 million items? And they'll probably say, worry about like 1,000 for now, and we can deal with bigger numbers later. And even if the input size is really big, the best way to go about this is start solving for the simplest case, for a small input size. Especially pay attention to what kind of output. A really common gotcha is missing a detail in like the output specification. And for better or worse, part of what you are being evaluated on these things is attention to detail. And that's why having a process and talking through stuff and double checking stuff and writing stuff down in comments or on a piece of paper, I think, is really the way to go. because my memory kind of sucks. Like if I don't do this, I always end up, I get the problem right, but then, you know, I output the string, but I forget I was supposed to add an exclamation point on the end or something, and that counts against you. And it should, in the context of that this is the program that we're asked to implement. I would then like pseudocode like a simplest possible version of the problem. Talk through it if you haven't with the interviewer. Depending on your comfort level with writing code, you may want to write some code here, but there's something to be said for pseudo coding it out, because you also want to explain your approach, because there's going to be multiple approaches more often than not, some better than others. And so it's always worth writing out the approach without getting into all the details of code and dealing with, you know, pointers or iterating through arrays and stuff. And then just checking in with your interviewer and saying like, hey, does this make sense to you? Do you have any feedback? Because the interviewer really kind of is your ally here. And if you're going down a wrong path, they may give you a little bit of a course correction. But they're going to look for you to check in with them to give them that opportunity. So it's to your benefit to make this as collaborative as possible. And now get into writing some code and work in really small chunks, get each little bit working. You don't want like 10, 20 lines and then you run the whole thing and you have a bug. You know, write 2 lines of code and then run it. Again, get the simplest possible implementation working first. Don't worry about large input sizes. Don't worry about edge cases. You can add those in as you get the core part of the algorithm working, and keep talking as you go. And when, you know, you inevitably like make a bug or realize that there's an issue or a problem, talk about that problem. That's really what you want to surface and talk through, and just keep talking through the solution together. And finally, do be prepared that once you get something working, the interviewer might ask you to do a variation or add more stuff, and not to get fazed by that. That's actually a good sign. So I know this sounds like a lot of stuff. The good news is, again, to kind of go back to this slide, the process is pretty simple. Repeat the question, understand the algorithm, explain your approach, pseudocode with the interviewer, code the simplest possible implementation. Always make sure your code works, like run it every couple lines with some test data. And then you can talk about how you want to test it and handle edge cases and stuff. And this LeetCode is honestly a great way to practice this. You know, you can have a checklist on a piece of paper, and you should, and you can practice this process with yourself. But Benjamin and I are going to demo it today, and then you all will break into pairs, and you won't interview each other, but you'll pair program together and explicitly practice using this process. And then next time you'll do it on your own with the LeetCode problem. So that's sort of my speech on how to tackle these whiteboard problems. Let me go ahead and stop sharing my screen. Let me also, this is in our, the doc is in our curriculum repo. It's under optional lessons, and I'm sharing the link in the Zoom chat and the class Slack. And before Benjamin and I dive in here, I wanted to see if folks have any questions sort of about tackling these whiteboarding problems and this whole process that I just walked through, because I know I kind of covered a lot of ground. Okay. Benjamin, should we do it?
Yeah, just give me 1 second.
Yep, no sweat. And I'm going to get myself set up as well. Yeah, and I think the most important thing to emphasize here, folks, is on mock interview day, by far the most feedback I get is that the interviewer says, I expected the student to ask more questions. There's really no such thing as as a bad question in this scenario. Like it really only will help because trying to like guess is not going to help. The best thing to do if you're not sure is say, hey, I'm not sure, but I think it's this. Is that sort of in the ballpark, and see what they say. And let me go ahead and pull up the problem that I want here. And Benjamin, do you have a preference for doing this problem in LeetCode or in VS Code?
I would say let's do it in LeetCode because the most common situation is that you're not doing it in your own environment. You're doing it in some kind of controlled environment, and it is worth seeing that because the first thing you end up seeing is like, okay, so here I am, right? I'm in LeetCode.
Yeah.
So first thing to get familiar with, let's just say the interview hasn't officially started yet. I'm just talking as an instructor now. First thing to get familiar with is just, there's some kind of interface. They're always different. Usually they'll send you a link beforehand and these sites usually have like, okay, this isn't your interview yet, but here's a trial, like a sample problem so you can see the interface. So I see there's like a description here and I can see like, it's even telling me like, here's what you could expect about your input and the output, etc. Then I could see here, like for instance, I could drop down. So you usually can choose the programming language you want to work with.
Yeah.
So for instance, and there's usually no problem here with like changing something like that, but usually they're going to predefine the function and then you don't want to do anything with that because that is what the test runner is going to pick up. And then notice I'm going to try and hit run or submit it. So you need to log in, sign up. So you definitely want to do that before the interview, which is make sure you just have an account on that site. So this is just sort of like pre stuff where, like, what the hell is oh, sorry, shouldn't say that, but like, I don't know if I remember. There we go. So I do have a GitHub one. And then again, like, it's good to just see like, okay, can I, the interview hasn't even started, but can I return something? And can I console.log something? So I just want to see that I can do both of those. And then I'll hit run. And when I hit run, it says like, right, that wasn't something you can return. You have to return something that's in array. So I fix that. I'll run it again.
Yeah.
And I'll see here. Yep.
And I would even say like what you're doing now, it depends on the specifics of how the interview is run, but this is a great way to start off, once the interview starts too, like cover the basics of make sure like you can run the function and you can get like a print statement or a console log and that like everything is working before diving into the problem.
Exactly. Yeah. So, I mean, and in general, in programming, like, it's good to just check every step. And on a new platform, you're just checking, like, right, the function runs. It was looking for a 9 or it was looking for a 0, 1, and I just gave it 1. So my output is wrong. And then I also saw some standard out. And then there's, more to this. I believe I can even add, I'm pretty sure there's a way I could add cases and stuff. Right, like that. I can add my own test cases, things like that. But yeah, so that's just starting out. Now, how about we start the interview proper, and I'll just do things how I would normally do them. And I just want to say to all the students, it makes sense that you wouldn't be used to this because you haven't done it before, but you'll see like having nothing to do with the problem or whether I can solve it. I've done these enough that I kind of know like the dance. So
yeah. And LeetCode is a good platform to get familiar with. And as I mentioned yesterday, you all want to spend some time on like the most popular LeetCode problems and definitely ask in advance, like what coding platform should I use? But once you get familiar with LeetCode, like HackerRank and all the others are relatively similar. Yeah. And right now, as you all start practicing this stuff, don't worry too much about like the time, paying attention to time. Once you get comfortable with the process, that is something that you want to do, because that is part of what you're being assessed on as well, is you know, not spending 30 minutes chasing a bug.
Yeah.
And in that sense, I think we were saying like 20 minutes feels like a good amount of time to do on this, so I can kind of officially kick it off whenever you're ready.
Yeah, I'll tell you in a second. I just wanted to point this out, and I can share the link as well. But there's this thing called Pramp, P-R-A-M-P. It's worth knowing about. If you sign up for free, you get like a handful of these interviews. So I have like 6 credits for some reason. As you see, I've only done this once in my life, and it was years ago. But the idea is this actually gives you a live interview where you actually do a practice interview with a real live interviewer. And so that'll give you something LeetCode doesn't give you, which LeetCode lets you practice the problems, but it doesn't let you necessarily practice interviewing. And as you can see here, there was like peer feedback. So, you know, did relatively well, but I haven't read all this. That could have been bad. But basically, like, you can actually see some feedback, and that's important.
Yeah, highly recommended. And I think we might have a discount code for Pramp for students.
Okay, so yeah, whenever you want to start that.
Yeah, let's do it. Yeah, Benjamin, thank you so much for interviewing with Megacorp, and you know, your background is really impressive, and we just want to work through a little programming problem together. So let's take 20 minutes and dive into this problem.
All right, cool. So I'm going to read the problem first. Given an array of integers num and an integer target, return indices of the 2 numbers such that they add up to the target. Can assume there's exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so they're giving me some examples. I want to just open up a comment thing to start thinking about them. So, right, if I'm given an array like 2, 7, 11, 15, and my target I'm looking for is 9, then I see that 2 and 7 add up to 9. And so I would return like 0, 1, because 0 is the index of 2 and 1 is the index of 7. And 2 and 7 together add up to 9.
Yeah.
So I understand the basic problem. Is that correct?
Correct.
All right, cool. So I'm going to look at these other examples in case they tell me anything about edge cases. So I see, right, I could have like 3, 2, 4, and then target equals 6. And let me see. So like, if I was looking at that, it would be like 3, 2, 4, and I'm looking for a 6. So looking through it, I could say like, okay, well, I see a 3, and based on what it says, I can't use that 3 twice, right? So I couldn't return like 0, 0, right? Or could I?
That's correct. I believe you can only use each element in the array once.
Right, so I can't use an element twice. So in this case, like I have 3, and I could do like 3, 2, but that's 5, 3, 4, that's 7. So I don't have it there. Then I move on, and then I'd look 2, 4, and 2, 4 does work. That adds up to 6. So that would be index 1 and index 2, and that's an answer there.
Yep, exactly.
And then I see this next example is sort of like the most basic case where that's the solution, 3 and 3. And so, okay, so I have some questions. I think I know the answers based on what it's saying, but like, could I ever get like an empty array as input?
It's a good question. Let me actually look at the problem definition to make sure I don't give you a wrong answer. So according to the constraints, no, the length of the array will always be at least 2.
Okay.
So you'll never get an empty array.
Yeah. And it looks like I could have the same number multiple times. So there's nothing wrong with that. But I need to make sure that they all add up to the value. So I can never get an input like this, right? I can never get a target of 4, and it's impossible to get that with the input, right? I'm guaranteed exactly one solution.
That is correct. You will always have exactly one and not more than one solution.
Okay. And looking through this, it looks like the numbers and also the target could theoretically be very large, and it could also go negative.
Yeah, that's correct. We have a pretty
Yeah.
wide range there, and that is something we can talk about more, how to kind of handle that and talk about performance if there's time.
Yeah, and it looks like based on this, I can assume it's going to be whole numbers. I mean, to be honest, it's not that explicit about it, um, but I can assume it's going to be whole numbers and not something like 1.72 and 2.12. Not that that would necessarily change the algorithm, but it could, in case, if these were really big numbers, sometimes there's floating point issues.
That's correct. It
Okay,
does
so
show integers, and I think I'm a little rusty, but I think that essentially means the
yeah,
same thing for our purposes.
yeah, and it says integers here, so I can assume that. Okay, so I think I understand what the
Couldn't check that.
input. I think I understand what the input can look like. And I think I understand edge cases in that I can't have an empty array. And at minimum, it's got to be two elements. And as part of that, at minimum, like if there's only two elements, those two elements have to be the solution because I'm guaranteed a single solution, at
Yes,
least one. Yeah. And
that's
then it
correct.
looks like I can return it in any order. So in the case of this one, 2, 7, 11, 15, if I return 1, 0 instead of 0, 1, it should still count that as good.
That's also correct.
Hmm.
Yeah, the
Okay.
output, we just need an unordered list of the two indices that add up of the numbers of the integers that add up to our sum.
Yeah. So in terms of thinking about the algorithm, let me just use this example to start. I guess I could write nums and I could write, target just so I have them here. So if I walk through this, I would kind of say like, okay, look at each number kind of in a window. So if I were to draw this, I'm not an Excalibur, but like basically I would look like at 2 and 7, and then I would look at 2 and 11, and then I would look at 2 and 15. And then I'd move on after that. When I'm looking at 7, I wouldn't look at 7 and 2 because I've already seen that. I'd look at 7, 11, then 7 and 15. And then finally, I'd look at 11 and 15. And then once I do that, I'm done. So I'm only going to look at, I'm going to look at each element for each other element, but I won't repeat any unnecessary work. So that means I'll be looking at, I guess let's give an example where it's not actually in there just to make sure I have to look at everything because we care about worst case. So like I would look at 2 plus 7 and, check is that 100? And if it's not, then I move on. So I'm going to check 2 against 11. Again, not true. 2 against 15. Then 7 plus 11, then 7 plus 15. And then finally 11 plus 15. And then I'm done. So that's like a naive solution. And I see down here it's saying like, can you do better than ON squared? And what I just described is ON squared because
I
even
was
though
about to I was about to ask about the time complexity because I kind of saw you already going in that direction. Yeah.
yeah, so even though I don't have to look at every element for every other element, I know enough about the complexity stuff to know that this still counts as ON squared because for 4 elements, or for this element, I have to look at 3 others. For this element, I have to look at 2 others. For this element, I have to look at 1 other. And the way that scales up is O of n squared. So, it looks like, if you're saying this, there probably is a better way, but I just want to solve it the ON squared way, make sure that it works, and then I can work on doing it better.
Yeah. I think that sounds great. And we just so on time, we're a little under halfway through. We've got about 12 minutes left. But honestly, it seems like you're on a pretty good path and we're moving at a pretty good pace. So don't worry too much
Okay.
about that.
Okay, yeah. So I just want to see that I pass all my test cases and I can submit, and then I'll worry about doing it better. But we feel good with this algorithm I have so far of, looking at each pair.
Yeah, I think you've analyzed the problem well and identified like the constraints, uh,
Mm-hmm.
and what we need to output, and that your approach, it looks like a good brute force solution to the problem.
Sounds good. Okay, so I'm going to make a double for loop just to get my indices. So I'm going to start this one at 1, and then it's nums dot length. And then, so this is going to take me through all 4 indices, 0, 1, 0, 1, 2, 3. I'm realizing I actually only want to go 0, 1, 2. So I'll minus 1 there. And then inside here, I want to look at every other pair. So that one is going to say, if this was 0, then I want to start with 1. If this was 2, then I would want to start with 3. So I'll take I, whatever it is, and add 1. And that one also cannot go beyond nums.length. And I'll plus 1, 1 there. And just to see that I'm printing out all the things I care about, I'm just going to print out that I and J to make sure that those are the pairs I'm getting.
Yeah.
And then I think just to make sure this works, I'll return some dummy thing like that. Okay.
That sounds good. And I think that's the heart of the logic of this approach right there.
Yeah. I wonder if I just ran into an infinite loop if I did something foolish. Yes, I did. I see that there's that. I said if I is less, so that's got to be a J there. So hopefully this times out so that I can do it again. Okay, so that sometimes happens and you got to be careful about that, which is why it's good to test things. So now, right, so I did 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, 2, 3, and that's all of them. And just to make sure, again, I can actually just see that that's what I'm grabbing from nums. So just make sure those are the pairs I'm thinking about.
Yeah, and I think that's correct. I'm looking at, because 0 is 2, 1 is 7, and 2 is 11.
Yeah, so 2, 7, 2, 11, 2, 15. Yeah, so it looks like I'm doing this correctly for all of them. Let's see in this case. Yeah, so I'm not doing more or less than I need to. So now that I have the nums I and the nums j, let me take out the console.log part. I think I just want to add them together. And when I add them together, I want to know if they're equal to the target. So I'll say if these 2 that I just grabbed are identical to the target, then in that case, I can return early and return true. Actually, I'm not returning true, right? I'm returning I and J. Oh, and based on what it said, there's no way it's not going to return. Like, I don't even need this technically because I'm definitely going to get a solution. I mean, in the real world, I might want to keep something there.
I think it's not the worst idea to leave it there for less breakable code, even if it won't be called. But you're absolutely correct that we should never see that empty array returned.
Yeah, so it looks like the way I'm doing it is passing all the test cases. So because I'm passing all the test cases, I'll submit now. And that will run it against a whole bunch of test cases I haven't seen and give me a little like performance analysis. So that, oh, it's over here. Okay. So yeah, it's telling me that I did. If it's accepted, then I passed all those tests. And it's saying that I beat 41% of users in terms of runtime. I beat 94% of users in terms of memory. Which is not always the best metric. That's not necessarily big O, but it still tells me something. But the fact that my runtime is not beating, the majority implies there is that better solution. And if I go back here, it's telling me like, is there a better solution than O(n) squared?
Yeah, and in general, with n squared, I feel like it's always worth. Sometimes there may not be a better solution, but it's often worth asking that question.
Right. Yeah, that is true. I mean, in general, unless it's constant time, you can always ask, should I try for better? So yeah, I want something better than O(n) squared. And when I look through this, like the problem is that it seems like I have to look through all of them. For each one of these, I have to look through, for 2, I have to look through all the others. For 7, I have to look through all the others. So I'm trying to figure out a way that is better than that. Breaking out of the conceit of the interview for a second, I'll tell students that I've seen this problem before. And so I know a way of doing this. And this probably wouldn't be intuitive to you. You probably wouldn't come up with it in the middle of an interview. And that's why you practice this stuff, because the more of it you see, the easier it is to come up with clever things. because coming up with a clever thing in real time is really hard. But I noticed that we're working just with numbers, and numbers have special properties. So because numbers are numbers, I can kind of work with them as numbers, and that might help. So something I can think about is I could create like a complements list. And then using that target, I could create a new list where I say, what are the complements of everything in this list? So the complement of 2, 9 minus 2 would be 7. 9 minus 7 would be 2. 9 minus 11 would be -2. 9 minus 15 would be -6. So
Sorry to jump in. I think I understand, but actually to help me a bit, would you mind maybe adjusting our sample data so that the matching pairs aren't right next to each other? So when we like think through it, like
sure, yeah. So I can just give like a random. So that's just a random set of numbers. And what's an example? Like, let's say 5 and 22, right? I'm looking for 26.
27.
27. Good point.
Yeah.
So I'm looking for 27.
Perfect.
And the algorithm I'm talking about now is the first thing I'm going to do is walk through this list and say, okay, what are the complements? And I'm just going to take the target and then minus that current num. So that'll be 27 minus 1 is 26. Minus 5 is 22. Minus 11 is 16. Am I right?
Yes.
24 and then 5?
Yes.
Okay, cool. So I have this list of complements, and then how does that help me? Well, I want to know pairs. And so if I see a 1, then there has to be a 26 somewhere in the list. If I see a 5, then it means there has to be a 22 somewhere else in the list. And that's kind of how I know. So basically, I can iterate through the nums and the complements at the same time. And then I say, like, once I create the complements, I could say, okay, looking at 1, is there a 26 anywhere in nums? Or sorry, I mean, I guess what I want is,
So
yeah,
you're on the right path here. So we have the complements. And we do want to iterate through the list, and we're interested in, like, when I'm iterating through that nums list, let's say I get to 22 at the end. What do I want to do with the complements list, and how will that help me? Like if we've been creating the complements as we go, and now we've gotten to the very end of this array in our example.
Yeah, well, I'm going to, so let's say I build up that complements list, then I want to walk through nums and say, is 1, no, so I have 1 and I have 26. It's like I want to walk through the complements list and then say, is a 26 anywhere in nums? Is a 22 anywhere in nums? Okay, well, if I see a 22, then I'm in then I'm good. But what I'm noticing is I'm going to have an issue, because if I'm looking through that list, I'm going to have to walk through the whole list. I need sort of, that's still going to be the same O(n) squared. So I need like constant time lookup. And I would not normally know this myself, but luckily I have the chat, and Eric Bowman says hash map. So that's a really great hint from Eric. You won't get that in the real world. But a hash map is exactly what I want. So that's a great hack for interviews in general. That a hash map.
I've gotten hints like that, but it really does depend on the interviewer.
Of course, right. And just breaking out for a second, some meta talk. Pay attention to an interviewer's face. Interviewers want to give you hints, but you have to stop talking for a second and allow them to. And so it always depends on the interviewer. I've had interviewers that just stonewall. They're just like, show me what you got. But a lot of interviews want to help you. And if they see you going down the wrong track, their faces turn, and you just have to get quiet and say, and then they'll say, hey, maybe this, or have you thought, like, they're trying to hint you. Right. So back to this, it's like I have this list, and then I want to build up the complements thing. And then maybe what that looks like is an array. And then I say, okay, 27 minus 1 is, 26. I can instantly look that up. And let's just say I'm going to put like true in there for now.
What would be,
or actually, what?
I was going to say there's something a little more useful than true that we can put in there.
Yeah, maybe the index, right? I think that's where you're going. Right. Yeah. So I actually want to keep track. 26 relates to 0. And then 27 minus 5, 22 relates to 1. The math is hard. 16 relates to 2. 24 relates to 3. And then finally 5 relates to 4. Okay. And now I'm going to walk through this and I'm going to say, so once I have the complements list, which I built up using nums, now I walk through nums again and I say, is there a 1 in there? And I can instantly look it up. No, there isn't. Is there a 5 in there? I can instantly look it up and I see, yeah, 4 is the complement. And it's only if I walk through this whole list and I didn't find anything in the complements that I would that I would have my worst case scenario.
Is it possible we would never find anything in the complements?
No, you're right. The nature of this is that I would always find something. That's a good point. And then I can see that there's going to be a possible issue. So maybe we should work through it now. So let's say I had like, let's say the target was 10. Okay. So we know that if I had 2 5s in there, 5 plus 5 equals 10. But if I have a target of 10, then maybe I would build this up and I'd say, okay, 10 minus 1 is 9. 10 minus 5 is 5. 10 minus 11 is -1. 10 minus 3 is 7. 10 minus 22 is -12. And then I start walking through this for the second part and I say, okay, is there a 1 in there? No. Is there a 5 in there? Yes, there is a 5 in there. The problem is that that 5 has the exact same index as the index I'm currently looking at, which means I'm using that 5 twice. That's not good. So
how did I apologize. I missed. How did we end up with say that part about the index again?
So basically the reason I'm using a target of 10 is that I know there's a problem here where if I just have a 5, well, 5 plus 5 equals 10, but I can't use the same index twice. And so when I built this up, I gave the complements, right? Mm-hmm. And yet when I'm at 1, I see there's no 1. When I'm at 5, I see there is a 5, but it's the same 5.
I see.
I'm currently looking at that complement is only there because it's half of the target. That's not, I can't return 1 and 1. So that's an issue. And then the other issue is that let's say I had another 5. Sorry, you were about to say something?
Yeah, I think you've got about like 70% of the problem here. And we did hit the 20-minute mark, but we do have a bit more time, so we can like take 10 more minutes.
Yeah,
so
and we did talk
with like the interviewer head on, sort of mock interviewer. So the 2 things I want to mention is, again, first, the problem design really helps us here because there's always going to be 2 numbers that sum up to our target. And the other thing is, I wanted to mention, I'm not actually sure if we have to go through the array twice. I wonder if constructing complements as we go can take us to a solution.
I don't think it will, because we have to build up the whole complements list before we can then look through and say if there's a complement. So like, let's say there's a 9 in here. If I'm walking through this, I'll say, oh, complements for 1 is 9. Mm-hmm. Oh, I think I see what you're saying, that by the time I get here, the 9 is there.
Yeah.
Yeah, that could work. I don't think that helps me much in terms of big O, because in terms of big O, walking through the list to create the complements list is O of n. And then if after that I walk through the list again, not nested, but just after it, it's just O of n plus O of n, which is the same as O of n. So
that's a good point.
Yeah.
That's a good point.
But
we may only need to do it once because of the guarantee there is always a solution, but I'm honestly not certain
That
about
too, yeah,
it.
that's
And
possible.
you're absolutely right that it actually it doesn't make a big difference if we're looking
Yeah.
at their two end.
But it is worth so breaking out of the interview again, I'm just going to say one, people will sometimes challenge you on something and they're actually giving you sort of a false hint. They're giving you a red herring. They're trying to see if you stick to your guns and if you can explain why the way you want to approach it is correct. So Adam doing that, he could have known, no, that's actually not a better way. I'm just asking. And part of being a good engineer is you're more concerned with the truth than doing it the way that the person's asking you to, because they want the truth really ultimately. And then the other thing that is probably worth showing is that so kind of what I did right now is I solved it, but I didn't solve it in the best way. And then I'm trying to solve it. I'm working through the algorithm and I'm talking about how it's better complexity analysis wise, but I might hit the time limit. And this has happened to me many times where the person says, okay, good, we hit the time limit, we're moving on to like the next stage of the interview or something, or the interview's over, but that doesn't mean you failed because it's not really about solving the problem, it's about having this conversation. And
Yeah.
the better you can have the conversation, and I'll tell you, I thought I used to work at Microsoft. I assumed I failed that interview because they asked me a problem and I did not solve it. I actually passed that interview because I had the conversation successfully. But I didn't think I did because I assumed, oh, they want me to solve everything correctly. So it's not actually required that you get the solution, but that you can have the like in the ideal scenario, you and the interviewer are now colleagues, and they're kind of seeing like, hey, if we had this problem, we were kind of pairing on it. How do you think about things? How do we think together? Because you're going to be some people are very good at programming, but they can't work with other people. And that tends to not scale up terribly well. It's better to be not nearly as good of a programmer, but be able to have the conversation and learn from somebody else. So that's kind of what you're being tested
Yeah. And I
on.
feel like that's really pretty much what we were doing. And, there, it is not, it depends on the interviewer. I did some preparation for this. I probably should have done a bit more so I could be a bit more definitive sometimes in some of my answers. But depending on the problem and the direction that you go in, there may be points where the interviewer says, like, I think so, but they're not, certain. And then you both are really colleagues. And sort of from the interviewer perspective here, like the key piece of this more efficient implementation was realizing like, okay, we've got this complements like dictionary or hash map. And the way I can use it is to look to see if we already have that complement, to see, oh, we have 9 in here already. Perfect. That means that I can use 9 and add it up with whatever's at index 0, the one.
Yeah.
And that's the part we got to. And if this was in a real interview situation, I probably would have, if we were short on time, I would have said, well, looks good. I think we got to the important part. And I can tell from like how comfortably and easily you implemented like the JavaScript for the brute force solution that, you would be able to implement this without too much of a problem. So that's sort of, Benjamin like demonstrated his JavaScript programming competence early on. So then when we kind of got to the conceptual solution here, that was like, 80% of or 90% or whatever of what we're looking for. And obviously I have the benefit of I did do a little review of this, and Benjamin, I'm probably guessing, though you've seen this before, you went into it cold.
Yeah, according to this, I've solved this problem many times now in different languages over the years. Going all the way back to 2018, I was probably just interviewing for a job then and actually doing trying to get it right. But yeah, so part of the takeaway here, which I think is important, is that you notice like this was kind of the smallest part of it, like writing the algorithm itself in a language. And that's kind of why, like they know in interviewing, maybe you're an expert in Java and the job's in Rust. And so maybe you don't know Rust that well. They're not asking you to program in Rust because the common language behind every language is algorithms. And so you can write and think about code in a way that doesn't require you to know a coding language. Like how many coding languages did Alan Turing know? Right? He knew zero. He was not. He was not a good programmer. Right? No, he could think about computer science, and languages didn't exist yet. But the idea is a language is just this sort of concrete implementation, and they want you to use the one you know.
Yeah.
But all this thinking can happen just as thinking.
I did once submit a take-home challenge in a language that my interviewers probably did not know, and in hindsight, I don't think I did myself any favors there. But realistically, that's not going to be an issue for anyone because JavaScript and Python are pretty universal.
But no, there's a good point there in that I've done the same thing where I had an interview and Java was ultimately in this language called OCaml, which is
Oh, that's
pretty
awesome! I've never.
unique. And I took a college class in OCaml. I love OCaml, but I didn't have that much experience with it, especially professionally, and I hadn't used it in like over a year. So even though I did the interview in OCaml, I didn't do that well. And in part, I didn't do that well because I did it in OCaml, and they gave me the option to use any language I wanted. So I think like basically you really want to choose the language you're absolutely most comfortable with and just stick to that language because you won't be penalized for using not their language.
Yeah.
And the only way you'll get bonus points for using their language is if you're really comfortable with it, that it doesn't impact you negatively at all. Because then you're showing, hey, I'm already very good at this language.
And the language I chose, this language Elixir, was like a little more esoteric than like Python or JavaScript. But really, the problem there was I over-engineered and took too long. That I did it in a language that they were less familiar with is probably just the icing on the cake. But like Python, JavaScript, Java, like PHP, Ruby, all of those are pretty readable for anyone who's going to be doing any interviewing of us.
Yeah. And you just want to, part of the reason you want to use the language of your choice is that if you do all the problems in the language of your choice, you kind of learn like, oh, right, I have this method or I have this, built-in library. And those are going to give me the things I want. So like if I didn't know how to quickly create a hash map, i.e. an object in JavaScript, I wouldn't have been able to work with this. But because I do, I have that tool. So basically you want to know your tools.
And that actually raises a really important point that we haven't mentioned yet. Pick the language that you want to do your interviewing in, probably Python or JavaScript. And Benjamin, unless you feel otherwise, what I sort of recommend is stick to that one language because like you're saying, you want to know your tools. And I've tried to do one interview in one language and another interview like later that week in another language, and it's always harder than it seems and not worth it.
Yeah. Basically, pick your language. I agree with that 100% because even though it's sometimes allowed, it doesn't look especially good if you have to look things up. Yeah. And so you just, obviously for some things you might have to, but for most of these things, like if I wanted to, like I'm curious to the class right now. Let's just say in my code, I had something that looked like this. And let's say I knew that I wanted to add a 4 right here, right? So how do I accomplish that in JavaScript? Does anyone know off the top of their head? I want to put a 4 right after the 5 in this array.
You do like a slice?
Do you do a slice?
The splice?
Splice, yeah. And there's a good chance you might not remember, like splice is something you're not familiar with unless you're working in JavaScript all the time. And notice it's not giving me any hints. So I need to actually know, oh, the way splice works is I take that array, it's nums.splice, then I take the index in which I want to start adding it. So 0, 1, I want to add it after the 1. The second argument is I want to delete nothing. And then the third argument is the thing I want to add there. So I'm pretty sure if I did this, I'm not even sure I'm right. But let me just
say, I am rusty enough with JavaScript where I would have to look up splice.
Yeah, but let me just, exactly right. So the idea is like, it's not about intelligence or anything like that, but you're going to be rustier or not with something. So let me just see if I'm right here, if I did the correct thing. Why is it upset about?
Because it's const.
No, it's because, right, it's already coming in, right? So I'm going to say,
yeah,
just call it nums2. But let's just see that. Right. So it wasn't quite right. As in, I added it at the one place, but I actually probably want to add it here. And I think that is right. But that's something I can, check with console.log. But the idea is like, if you're not able to look things up, you want to know about your tools. And that whichever language you're used to is going to have tools in a certain way. Tools being anything the language can do. And you're not generally allowed to import libraries. So basically, you want to know your built-in tools well, and arrays and objects, things like that are going to help you a lot. So use the one where you're most comfortable, because I'm sure some of you know how to do this in Python, and I probably, off the top of my head, don't. So, it's really about just using the tool you're most comfortable with. But yeah, we're a few minutes over. So, Adam, anything else you want to say?
Just to add to what you're saying, like Benjamin, I really liked when you did that nested for loop, you added those like console log statements, and then like added the actual values to like double check that things were correct. And then you actually realize, oh, I had like an I instead of a J there. And the same way, in that doc, I was saying like run your code like every 2 lines with some console logs, that's the way to use Splice and get it right, is use it and then console log it and run it. And then if you're like, oh, I had this like index wrong in my Splice operation, your interviewer isn't going to hold that against you. They're going to be like, cool, they're double checking their work. That's great to see. And then you fix it and you get it corrected and you can move on.
My sense is console.log is, or, any kind of printing to the console is your friend, especially in an environment like this. And you just want to check things to make sure, because making mistakes is almost unavoidable. You will do it. And so the only way out of making mistakes, other than being perfect, which is not going to happen, is that you check your work as you go, just so you're not making assumptions. You're not getting to the very end where you have a ton of code, and then your bug is affecting you when you have a ton of code, but you don't know where that, when that started.
Yeah, totally. And I think that's the perfect